Electrostatics. In the previous video we have used Coulomb's law to find the forces acting between two charges given by the expression F equals to K Q1 Q2 by R square. Now what will happen if there are more than two charges present? In that case you need to find the resultant force that will be equals to sum of all the individual forces acting on a given charge. Unlike gravitational force, electrical force is both attractive for unlike charges and repulsive for like charges. You need to keep this in mind to find the resultant force. Now for this system, if we want to find the resultant force acting on the positive charge, then it is obvious that since all the other charges are negative, they all exert an attractive force on this charge. So the resultant force will act in opposite directions. Now if all these charges were negative, then the resultant force on the central charge will be repulsive. All the other charges will push this force away from themselves. Similarly, for a combination of like charges and unlike charges, here the resultant force on the central charge will be both attractive and repulsive, attractive from the positive charges and repulsive from the negative charges. Therefore, it will experience a net resultant force towards the left side. Let us solve a numerical for understanding it in the mathematical form. Here 3 point charges are placed at the following points on the axis: plus 2 microcoulomb at x equals to 0, minus 3 microcoulomb at x equals to 40 centimeter and minus 5 microcoulomb at x equals to 120 centimeter. Find the resultant force on the minus 3 microcoulomb charge. Now here we have the axis. On that we have three charges Q1, Q2 and Q3 placed at x equals to 0, x equals to 40 centimeter and x equals to 120 centimeter, having charges plus 2 microcoulomb, minus 3 microcoulomb and minus 5 microcoulomb respectively. Based on the values, here x equals to 40 and x equals to 120 is the position. So the distance between them is 0.4 and 0.8 if we convert them to meter respectively. Now Q1 is positively charged, Q2 is negatively charged. So Q1 attracts Q2 while Q3 and Q2 they both are negatively charged, hence Q3 repulses Q2. Therefore the resultant force on Q2 will be equals to force on Q2 by Q1 plus force on Q2 by Q3. That will be equals to minus K Q1 Q2 by R1 square. Only the magnitude of charges is considered, minus K Q2 Q3, again magnitude only considered, upon R2 square. Here the negative sign indicates the direction of the applied force, which is along the negative x-axis. Substituting all the values and simplifying, you get the answer as F on Q2. The resultant force on Q2 will be equals to minus 0.55 Newton or 0.55 Newton towards the left side. Now pick up your reference books and practice more such numericals. I am also posting solved questions from books like H.C. Verma on my Facebook page, Physics Tutorials. Subscribe to the channel if you haven't already.